Okay, here we are with question 2, and it asks us to state our hypothesis clearly. So it's testing a correlation coefficient. So our initial null hypothesis is always that rho is equal to 0. And in this case, the alternative hypothesis is that rho is less than 0, is negative. And it's 5% correlation. So from the tables, we can see that the critical value is 0.6215. Okay, so critical value is 0.6215. And remember, this is for positive correlation, so we note, of course, the negative is the other way. So minus 0.6215 is actually greater than minus 0.915. So our recorded value, the actual value we got, the minus 0.915, is within the critical region, so that we can reject H0. So therefore reject H0. And so we say there is evidence at the 5% level to suggest a negative correlation. So there is evidence at 5% to suggest a negative correlation. Okay. So then part B says, suggest a possible reason. Well, she owns a clothes shop, so when the weather gets really hot, perhaps people don't go clothes shopping so much. So when the weather warms up, when the weather is hot, fewer people are clothes shopping. Something similar to that, something along those lines. So part C, Tesla suggests a linear regression model could be used. Well, the correlation coefficient is significant, so there is significant evidence of a negative correlation, so a linear model is suitable. So linear model suitable. Since correlation coefficient is significant. Okay, so we've got significant correlation coefficient there. Tesla calculated the linear regression as that, given interpretation of the gradient. So this means the gradient is there is 171 pounds less in takings per unit drop in temperature. So 171, this must be in context now, so 171 pounds less per week per unit drop in temperature. Sure, let's spell that correctly.